Welcome to today's deep dive. We've got a really fascinating set of source materials on the table for you today.
Yeah, we're looking at a press release from July 23rd, 2026 from a company called EON AI Ventures.
Right, and they're introducing this entirely new concept that they call the Work Intelligence Flywheel.
Which is quite a name, honestly.
It is, yeah. But our mission for this deep dive is to explore what looks like, a really radical shift in how massive high-risk industries handle their safety and efficiency.
Exactly, moving away from a reactive system.
Right, a system that basically just records disasters after they happen and moving toward a proactive one that actually prevents incidents right where they are born.
And, while the immediate focus of this material is on industrial technology, so think offshore oil rigs or massive chemical plants, the underlying theme is actually very universal.
Yeah, it's something everyone can relate to in some way.
We're really looking at the nature of human expertise. I mean, how we capture human intuition and how we record those really subtle things that a seasoned professional notices, but that a machine just completely misses.
I want you to imagine you're doing your job. You're going through your usual routine, navigating the inevitable hurdles of your day.
Like we all do.
Right. And you probably make a dozen little adaptations without even really thinking about it. Maybe your software is lagging, so you find a quick workaround.
Or you notice a slight error in a report and just fix it on the fly.
Exactly. You use your years of experience, you use your judgment, and you make those crucial decisions, and then you clock out.
And that's where the problem starts.
Yep. Imagine that the moment you walk out that door, every single piece of that hard-earned context, all those little adaptations and judgment calls, they just vanish into thin air.
They completely evaporate. The system you work for has absolutely no memory of how you just succeeded, only that the task was marked, complete.
Now, in a normal office, that vanishing knowledge is, it's just really annoying. It means the next person on shift tomorrow morning has to reinvent the wheel.
Right. It's frustrating, but nobody gets hurt.
Exactly. But when we scale that evaporation of human expertise up to billion-dollar high-risk industries, things change completely.
Oh, absolutely. We're talking about places dealing with immense physical forces, combustible materials, massive machinery.
And in those places, that lost knowledge goes from being an annoyance to being incredibly catastrophic.
It costs millions of dollars. And more importantly, it costs human lives.
So to really grasp why EON AI Ventures is pushing for such a massive technological overhaul, we first have to look at what modern industrial facilities are actually already doing today.
Because they aren't exactly flying blind right now.
Right, not at all. According to the source, a modern facility currently collects what they describe as a really powerful nervous system of data.
But they estimate this massive nervous system only makes up about 45% of a complete work record.
Which is wild when you think about how much data that 45% actually is. We're talking about millions of individual data points.
Yeah, it's a huge amount of information. You've got sensor data constantly reading pressure, flow rates, temperature.
And then we have set points and alarms from these things called SCADA and DCS systems, plus time series memory from data historians, and condition monitoring for things like vibration and corrosion on the pipes.
Let's actually ground some of that terminology for a second, just for anyone who isn't spending their days walking around an industrial plant.
Yeah, that would be helpful.
So SCADA and DCS systems, they're basically the central control hubs of the whole operation. They allow the operators to monitor and manipulate all that heavy machinery from a safe distance.
Like the classic control room you see in movies.
Exactly. And a data historian is pretty much exactly what it sounds like. It's a massive software database that just records all those sensor readings over time, so you can look back at the historical trends.
Okay, so if you were to walk into one of these modern control rooms, you'd see banks of glowing screens charting just every conceivable metric.
Yeah, it literally looks like a digital nervous system. It's incredibly sophisticated.
But the press release points out a really fatal flaw in this 45% of data. It only represents the consequences.
Right. It tells you that the pressure dropped or that an alarm fired, but only after the fact. The event has already happened.
And the human and financial costs of that specific blind spot are just staggering.
They really are. The source actually provides some pretty grim statistics from the International Association of Oil and Gas Producers.
Yeah, let's look at those. In 2024, upstream oil and gas recorded 32 fatalities across 21 separate incidents.
32 people.
And 41% of those deaths were caused by explosions, fires, and burns.
Which are exactly the kinds of massive events you would think a system of thousands of sensors would catch.
Right, but they don't catch it in time. And financially, the average offshore facility loses about $38 million a year just to unplanned downtime.
And the absolute worst performers, they lose over $88 million annually.
The press release says it really plainly, and this stuck with me. They say these aren't just accounting abstractions, these are people who didn't go home.
Yeah. When an offshore facility loses tens of millions of dollars to unplanned downtime, it means massive machinery has catastrophically failed, operations have violently halted.
People were in danger.
Exactly. Both the environment and the workforce have been put in immediate jeopardy. We've spent decades building these really brilliant systems that monitor the machine.
But we forgot the human part.
Right. We completely forgot to build systems that monitor the interaction between the machine and the human operating it.
Okay, let's unpack this. Because if this existing setup is already described as a powerful nervous system with, thousands of sensors and alarms, why is it failing to stop these million-dollar fatal disasters?
That's a great question.
I mean, think about it like a car's black box. Let's say you have a system in your car that only records the exact moment the airbag deploys.
Okay.
And it records the precise millisecond the speedometer drops to 0. Now, that data is perfectly accurate. It tells you with 100% certainty that a crash happened.
But it tells you absolutely nothing about why it happened.
Exactly. Was the driver distracted by their phone? Were the brakes cut? Was there black ice on the road?
You'd have no idea.
Right. If the industrial nervous system is just a black box recording the crash, it's completely useless for preventing the next crash.
What's fascinating here is that the sensors are actually doing exactly what they were designed to do. They're recording the explosion.
They're just doing their job.
Exactly. The failure really lies in our expectation of what that data can actually achieve for us. You just cannot prevent what you cannot see.
Right.
The disaster doesn't actually originate at the exact moment the pressure drops. It's born much earlier, entirely out of view of those control room sensors.
Where is it born then?
It's born in a moment of uncertainty on the factory floor. Or maybe it's a procedural boundary that was quietly crossed 3 shifts ago and nobody wrote it down.
Which means if the 45% we just talked about only shows the consequence, we have to go hunting for the root cause.
I like to look elsewhere, yeah.
Because if the sensors aren't where the incident starts, where does it actually begin? And the source drops a pretty massive statistic here.
It's a huge number.
They say more than 70% of oil and gas accidents trace back to human and organizational factors, not process signals.
Right. And human and organizational factors is a pretty broad umbrella term. We aren't just talking about someone accidentally leaning on the wrong big red button.
Sure, it's more subtle than that.
Much more subtle. We're talking about tiny errors in judgment, procedural lapses, gaps in a job safety analysis, or weaknesses in the permit-to-work systems.
So it's administrative, almost.
A lot of it, yeah. The root cause of an explosion might not be a broken valve. It might actually be a paperwork gap that allowed the wrong team to authorize work on a valve that wasn't actually fully isolated.
Wow. So these are human decisions, not mechanical failures.
Exactly. They are human choices, invisible to the DCS screens.
So EON AI Ventures claims that the decisive evidence needed to stop these disasters lives in what they call the missing 55%.
This is the missing piece of the puzzle.
And this is that knowledge we talked about at the beginning of the show, right? The knowledge that just evaporates the moment a job closes.
Right. Imagine a 30-year veteran retires, and they just take decades of incredible intuition out the door with them.
Or a worker makes a brilliant, super safe adaptation out on a rig in the freezing rain, but they never bother to write it down in the official log.
Or a near miss happens, everyone gets lucky, they take a deep breath, but the next crew coming on shift literally never hears a word about it.
Because that knowledge evaporates, the whole system basically lives in a state of perpetual amnesia.
That's a great way to put it, perpetual amnesia. And to fix this, EON proposes breaking down this missing 55% into 4 distinct measurable categories.
They're trying to put a structural mathematical framework around something that usually feels incredibly intangible.
Yeah, which is an ambitious goal.
Very. They break it down like this. First, 18% is field execution. Basically, what physically happened out there. The observations, the photos taken, offline readings.
Okay, that makes sense. Tangible things.
Right. Then, 15% is human expertise. These are the subtle cues and expert notices, the options they consider but reject, or that moment they decide to stop work because something just feels off.
The gut instinct stuff.
Exactly. Another 12% is plan and authority. So the authorized job, the documented hazards, the limits, and the required evidence to prove the work was done safely.
The paperwork side of things.
Right. And finally, 10% is simulation and governance, meaning the approved digital twin state of the facility and the strict rules for how those lessons can actually be reused.
Okay.
But here's where it gets really interesting. I look at those numbers and I have to push back pretty hard.
Oh, I don't blame you.
18% here, 15% for human expertise. This sounds incredibly precise for something as messy and subjective as a judgment call.
It does sound suspiciously exact.
Right. I mean, how do you mathematically quantify human intuition? Are they somehow putting a sensor on someone's gut feeling? Or is this just a slick marketing gimmick to sell some new AI software?
Well, if you actually dig into the fine print and the footnotes of the press release, EON explicitly states that this 55-35 split is a planning hypothesis.
A planning hypothesis, okay.
Right. These aren't rigidly audited universal statistics stamped by some regulatory body. It's a conceptual model meant to be calibrated per customer, per facility, and even per specific job type.
But still, even as just a planning hypothesis, assigning exactly 15% to something as abstract as human intuition, it seems like a massive stretch.
It's definitely the hardest part to swallow.
Because you still have to capture it somehow. How do you actually measure a gut feeling in a way that lets you put it in a database?
And that right there is the ultimate friction point of this entire technology.
Yeah.
But they aren't actually trying to read minds here. They're trying to digitize the footprint of that intuition.
A footprint? What does that look like?
Well, if an incredibly experienced worker pauses for 10 whole minutes before turning a critical valve, the system logs that unusual pause.
Oh, I see.
Or if they take a photo of a rusted flange and text it to a supervisor to ask a question before proceeding, the system ingests that photo and it registers that hesitation.
So it's looking for the outward signs of inner thought.
Exactly. It's looking for behavioral markers that indicate an expert's intuition is firing. The core philosophy here is that the work context half, the human half, simply must outweigh the sensor half.
Because, like we said earlier, the data proves that 70% of accidents originate in those human factors.
Right. You have to fish where the fish are.
Yeah, if 70% of your disasters start with human and organizational lapses, your safety systems really better be hyper-focused on human behavior, not just staring at a temperature gauge waiting for it to spike.
Exactly.
Think about your own job for a second. How much of your day is spent fixing minor errors that never actually make it into an official report?
Probably a lot more than we realize.
You just quietly fix a broken spreadsheet formula and move on with your day. But on an oil rig, failing to log that tiny informal workaround is exactly what leads to that 70% accident rate.
Because the next guy doesn't know about the workaround.
Right. But identifying this missing 55% is totally useless if it just continues to vanish at the end of every single shift. So how does EON actually force a rig to learn from that captured memory?
Well, they join this manufactured 55% with the existing 45% of sensor data. And together, that creates what they call a verified work episode.
A verified work episode, okay.
Think of it as a completely reconstructible digital record of one single mission, all the way from the original intent to the final outcome.
But a filing cabinet full of detailed incident reports doesn't actually prevent accidents if nobody ever reads them. I mean, we've all worked places where they make you fill out a form that just goes straight into a black hole.
Right, the data has to be active, which is where they introduce the Work Intelligence Flywheel.
Ah, there's the title of the press release.
Exactly. This is the engine that actively compounds the knowledge, rather than just passively storing it on a server somewhere. It uses 3 specific mechanisms to do this.
Okay, what's the first one?
The first is called Assess IQ, and this measures the delta, or the difference, between the approved plan and physical reality. And it gives feedback while the work is still live.
Okay, wait, let's break down how that actually works causally. How does an AI measure the difference between a paper plan and physical reality in real time? Is it using camera feeds or computer vision?
It's a synthesis of a lot of different inputs. Let's walk through an example.
Sure.
Let's say the digital permit, which is the plan and authority part, states that a specific pipe must be fully depressurized before any maintenance can begin.
Okay.
Natural language processing parses that specific text requirement. Meanwhile, the DCS sensors indicate that there is still residual pressure inside that specific pipe.
Oh, I see where this is going.
Right. And simultaneously, location tags, or maybe computer vision on the factory floor, show the maintenance crew physically entering that restricted zone.
So all these streams are coming together.
Exactly. Assess IQ flags the delta between what the paperwork says is safe, what the sensors say is currently happening and what the human beings are physically doing.
And it catches that discrepancy before a wrench ever touches the metal.
Exactly.
Mm.
Catches it live.
Okay, that makes perfect sense. It's constantly comparing the blueprint to the reality. Then they have a second mechanism called compound IQ, which scans across many different episodes to find recurring cues or deviations over time.
Finding the patterns.
Right. And finally, the third mechanism is the work intelligence distillery. This filters and packages the learned lesson and feeds it right back into the digital twin of the facility, the training scenarios, and the permits for the very next mission.
And we know this kind of thing works because the industry already knows data-driven approaches are effective. The source actually cites that using predictive approaches on just the existing 45% of sensor data reduces unplanned downtime by about 36%.
Just from the sensor data.
Right. That's a massive financial win based solely on analyzing reactive consequences. EON's entire argument is that if you can get a 36% improvement from the reactive data, the totally untapped, massive prize is targeting the root causes hidden in the missing 55%.
It's like a sports team studying game tape. If the coaching staff only ever looks at the final box score, who scored how many points, what the final score was, they might be able to make a few minor adjustments.
Right, but they're missing the how.
Exactly. The box score is the 45%. But studying the actual game tape, watching the footwork of the defense, seeing the subtle miscommunications between players before a play breaks down, that's the 55%.
Taking that sports analogy a step further, the flywheel means it isn't just the coaches watching the tape on Monday morning in an office.
Right.
It's feeding the insights from that game tape directly into the players' playbooks before the very next drive in the game.
That's incredible.
You're shifting from outcome analysis to behavioral analysis. The end result is that safety stops being a passive concept.
It stops being a motivational poster hanging in the break room.
Exactly. And it becomes an active, inherent property of the system itself.
So what does this all mean for the actual worker on the ground, though? Does turning safety into a property of the system mean human intuition is basically being replaced by AI?
That's a valid fear.
I mean, is the machine just going to strictly dictate every single micro move to the person out there in the freezing rain?
If we connect this to the bigger picture and look at the actual mechanics, it actually empowers the worker.
How so?
The flywheel isn't replacing human judgment. It's capturing it and distributing it. When the next crew arrives to do a really hazardous job, they don't have to guess. They arrive with the complete asset context and the previous crew's experience already in their hands.
Oh, that's huge.
If a worker last year noticed a really subtle warning cue that almost led to a near miss, the flywheel ensures that today's worker knows exactly what that cue looks like before they even start turning the wrench.
It's basically crowdsourced survival.
Yes, beautifully put. Crowdsourced survival.
That is a massive paradigm shift. But having a grand theory of compounding intelligence is one thing. Testing it is another entirely.
Very true.
We're talking about industries with fatal consequences. You wouldn't test a brand new parachute design by just jumping out of an airplane on day one.
No. You use a wind tunnel, you test the physics where it's safe.
Right.
And EON recommends a very specific, cautious path for proving this concept actually works. They explicitly state this needs to be tested first, where the ground truth is entirely known and where absolutely no one is at physical risk.
So what does the wind tunnel look like for an offshore oil rig?
EON suggests using specialized training centers equipped with physical things called skids.
Skids? What's a skid?
A skid is essentially a modular steel framework containing real valves, pipes, and machinery that are purely used for practice.
Okay, like a mock-up.
Exactly. They run a simulated process environment on these skids, coordinating teams between a mock control room and the physical field equipment.
They're basically playing out high-stakes escape rooms.
Pretty much.
They can manufacture these verified episodes in a completely safe sandbox. They can simulate rare and highly abnormal conditions that you hope never actually happen in real life, just to see if the flywheel successfully captures the human reaction to it.
Right. And only after proving it works there, in that controlled environment, do they move on to tightly bounded, customer-controlled field pilots on real rigs.
Which is smart.
That controlled testing environment is absolutely vital because it proves the system can actually capture those elusive human factors.
It proves it can capture the gut feelings.
Exactly. It ensures the AI is genuinely learning why things happen and how human beings naturally react to stress and ambiguity long before it's ever deployed into the wild.
Think about how much ground truth in your own workplace is just tribal knowledge.
Oh,
Information that isn't written anywhere, but every new hire just has to figure it out the hard way through trial and error.
we've all been that new hire.
Right. Now imagine a system actively watching the most experienced person in your office, learning their tricks, and automatically adding those tricks to the onboarding manual for the very next person.
That's exactly what they're doing here, just with highly combustible materials instead of spreadsheets.
Let's look back at the journey we've taken today. We started by exploring the fatal blind spot of modern industry, which is relying solely on a 45% nervous system of sensor data that only tells you a disaster happened after the fact.
The outcome data.
Right. Then we uncovered the missing 55%, the human and organizational factors where incidents are actually born, like those subtle judgment calls and procedural lapses.
The root causes.
Exactly. And finally, we examine the nuts and bolts of the work intelligence flywheel, diving into how systems like AssessIQ actually merge digital permits with physical sensors to capture evaporating human knowledge, and then compound it into a living system that actively feeds lessons forward.
It really is a comprehensive vision for the future of industrial safety. But there's one final detail buried in the About EON AI Ventures section of the press release that we absolutely need to highlight before we wrap up.
Oh, what's that?
EON states their purpose is to transform real operational experience into trusted work intelligence. But they emphasize that this intelligence is built to be, and I quote, independent of any single foundation model.
Independent of any single foundation model, meaning they aren't tying their entire ship to just one specific AI engine, like an OpenAI or Anthropic model.
This raises an important question, and it's a fascinating one to ponder. Foundation AI models the underlying architectures that power artificial intelligence. Right now, they're evolving at breakneck speed.
Yeah, they change every few months, it seems.
Right. What's cutting edge today might be entirely obsolete in 3 years. If EON's entire intelligence architecture is designed to survive independently of any specific AI model, what happens over the long term?
Oh, wow.
Could this work intelligence flywheel ultimately become a permanent, immortal repository of human expertise? That's deep. We could be looking at a system that captures the intuition of a worker today and continues to teach that exact intuition to new workers a century from now, long after the original AI tools that built the system have been completely replaced and forgotten.
We're talking about building digital monuments to human experience. That is just incredible to think about.
It really is.
As we wrap up today, I want to challenge you to look at your own work environment. When you pack up your bag and clock out today, ask yourself, what critical knowledge, what tiny, brilliant adaptation did you just make today that is evaporating into thin air the moment you walk out the door?
And what would happen if a system could catch it before it disappears?
Thank you so much for joining us on this deep dive. We'll catch you next time.